is
probability of
M
male, is it the same as probably male given Toyota? And we've calculated both of those.
Yeah.
What's probably male? 50%. What's the probability of male given Toyota? 4238, right? Those are not equal. Therefore, they are dependent. I like it. Because Toyota, if somebody tells me a Toyota owner happened, then they have less of a chance to be a man. It does sound a little weird, but it's all about the probability that is a person, that's a male person.
Yeah, that's more curious. More hybrids are owned by women.
Oh yeah, it's true. Of course, I just made these numbers up. The numbers I'm going to use on the test, on the quiz, are the numbers you give me for the survey. So whoever participates in the survey, you will become a part of the quiz. So I'll make a little, ooh, yay, thank you. It's almost like being in a movie, but not at all, really. There'll be a data point. Sounds like some after school special. What's my season? I have to really look and see. Alright. So this is the problem. You know I'm going to have this kind of problem on here. This is the one where you have to use the formulas. Could A and B be independent? That one is an idea. What do you check? We just did it. What's not true that should be true if they wanted to be independent? A given B probability has to be equal to A's probability, and they are not. So there you go. Could they be independent? No, the probability A given B is not equal to. Hell no. I like it. So yes, you can say help. Part B is a little bit more elusive. I don't just use that word because it's exclusive, but it's what's up? Yes. So this is asking, could they be? So in order for them to be mutually exclusive, what must be true? Must be 0. I like it. Do we have what we need to calculate A and B? How do I get probably A and B? How do I calculate that? I have A given B here, right?
Yes.
Probably B given A, but do I have B given A? So I want the probability of B times probably A given B. Now, without even doing the work, is that going to be 0? Hell no. Neither number is 0. Right? You guys get me? So I really want this to make sense. What's on the top of the given formula? What's on the top? So if A and B are mutually exclusive, that is 0. Therefore, this would have to be. So you could actually just say, since A and B is equal to 0.85, not 0, they can't be mutually exclusive. A and B can't be 0. In order for two things to be mutually exclusive, this must be 0. If this was 0, this would be 0. Is it 0? Oh, there you go. That's the kind of reasoning you have to use. Boy, I really like problem C. I'll show you. Whatever that is. What do you get here, by the way? Let's just do this. What is 0.4 times 0.85? 0.34. Okay. That's probably A and B. It's 0.34. Now, this question I should have asked earlier because we just calculated, but somehow you can figure out what the smallest this is. Now watch. I'm going to show you this, and one reason why I put this on this quiz is so you can see the idea behind it, so then you can do it in the future. This is not great, so I can do whatever I want to up here. Right? Probably A or B is equal to what? Probably A plus, probably B minus What is probability A plus probability B? 0.8 plus 0.4, what is that? 1.2. Does that make sense as a probability? No. So how much, what's this got to be at least in order to take that down to where it makes sense? 0.2. If this is 0.2, that becomes 1. Is that allowed? Can something have a probability of 1? Hell yes. That just means it's 100% chance to happen. So that's the way to answer that kind of. What's the smallest that could be? Look at the or. Whatever this is, however much it's too much, that's got to be what this takes care of. So it could be 0.2 or higher up until this goes to, 0. Then it's got to stop. But it can't be 0 anyway. So it's got to be at least 0.2 to make this probability come out to make sense. What's the largest probability can be? 1. If that was 0, it doesn't make any sense. I'm saying the probability of something is 1.2. That's not possible. You guys like that, huh? I'm sarcastic. So again, any probability statement I make, if the probability A and B was 0, what would be the probability A or B? It would be equal to 1.2. Is that legal? Is that physically possible? No. 120% chance of whatever, sun tomorrow. We just all burned to death. Whoa, 120%. I don't know what that means. So this has got to be at least 0.2 to make this come back to 1. Could it be 0.3? Sure. Could it be 0.8? Yes, but it's got to be at least 0.2 to make this make any sense. Okay. Oh, we already found the probability of A and B. Look at us overachievers. And now you got everything you need to do part E. What's the formula for that say? What's the formula say? Alright, sorry. What's the formula for B given A? What goes on the bottom? A. On the top is? And we figured that out, didn't we? We know what probably B and A is. 0.34. And what's probably A? We've known that from the beginning. 0.8. So it's whatever that is. I don't know. .425. Yes. All right. So you could get any questions that look like these or involve these ideas. Yes.
Is this tracking back going to be like basically the length of the quiz, or is it going to be?
No, one side.
One side
will be the approximate length of the quiz. Yeah, maybe a little shorter than that. Right. The other side was just something we did in class. This was something I wanted you guys to do on your own. We got time, unless you need to leave. It's college. You didn't.